Hey guys, Mr. Backerberg here. In this video, we're going to take a look at absolute value functions. As we're talking about absolute value, informally we would say that an absolute value function takes whatever's on the inside of it and turns it positive. Formally, we can define an absolute value using a piecewise function. So if we're looking at the absolute value of x, it's the opposite of x if you're dealing with x values that are less than 0. So if you're dealing with negative x values, it's going to take the opposite of that, which makes it positive. And then your second piece of the function says that it's just x if your x value is greater than or equal to 0. So if it's 0 or a positive number, then it doesn't change the value of x at all. It stays positive. Graphically, an absolute value is going to give us this V-shaped graph. If we start in the origin going out to the right-hand side, that's a line with a slope of 1. But if we look on the left-hand side, that's a line with a slope of -1 coming down into that origin. So that's what gives us that V shape to that graph. Taking a look at this example, we're going to sketch out a graph of an absolute value function, and then we're going to find its domain and range. So we're going to make a table of values to help us draw out a picture of this function. Now there's actually some transformations in here that we can use to help us out a little bit. This -1 on the end of the function, if we remember, that's a vertical shift that's going to move us down one space. And this -2 inside of those absolute value brackets, that's a horizontal shift, and horizontal shifts are always backwards. So -2 actually moves you to the right 2 spaces. So that tells me that the center point of my V-shaped graph is going to be at the point 2, -1, shifted right 2 and down 1. So as I'm making my table, I'm going to work my way out from there. So I'm going to go to 1 and then 0, but then I'm also going to go to 3 and then 4, again working out from that center point. So I'm going to plot out that 2, -1 right there, so that's going to be kind of the point of my V. I'm going to start by plugging in the 0. So if I take 0 and subtract 2, that's -2. If I take the absolute value of that, that turns into +2, but then I subtract 1 from that, and I get 1 as my answer. So at 0, we're up at 1. Plugging in 1 minus 2 is -1. Take the absolute value of that, turns it into +1. Subtract 1 from that, and we're at 0. So we've got 1, 0. Plugging in 3. 3 minus 2 is 1. The absolute value of 1 is still 1. Subtract 1 from that, and we get 0. So we can start to see our V shape developing. Last value we're going to plug in is the 4. 4 minus 2 is 2. The absolute value of that is still 2. And then subtract 1, and we get 1. So we can see the V shape to our graph there. So I'm going to connect each side of my graph. So there's our picture, but then we also want to talk about the domain and the range for this picture. So the domain means the x values that are safe to plug in. And things that we've talked about as far as things not being safe to plug in would be square roots of negatives or dividing by 0. Our function doesn't have any square roots, and it doesn't have any fractions in it with a variable on the bottom, so there aren't going to be any domain issues. So the domain is going to run from -infinity up to +infinity. I'm writing that out in interval notation using parentheses around the infinities. As far as the range is the y values, so we're going to read our graph from the bottom to the top. The lowest y value that we hit is -1, and that point is included because that point on the graph does exist. These lines extend up forever and ever and ever, so the range goes up to +infinity, and that always gets a parenthesis around it. That's going to be it for this video. Thanks for watching.